In section 1 of this chapter, we talked about the different types of energy, and thermal energy being one of them, and chemical energy being another. In this section, we're going to start looking at more specifically how thermal energy relates to a chemical reaction. The whole study of heat in a chemical reaction is called thermochemistry. It's a very important concept to us because not only is understanding matter transfer important, but understanding heat transfer and energy transfer is just as important. Now, the word heat itself has a lot of misconception. When we think of heat, we tend to think of a fireplace, or we think of a stove, or things like that. Heat, the general term of it is the transfer of thermal energies between two bodies that are different temperatures. Heat always flows from higher energy to lower energy. Now, again, heat doesn't always have to be just the stove or something hot like that. Your hand has heat energy. Even a cold object has some heat energy. And in place to a object that is lower energy or colder, it will flow in that direction. Let me give you an example again. If you put an ice cube in your hand and you hold it there, the general misconception is that the coldness is going into your hand, making your hand cold. Or on a snowy day, if you're out playing in the snow, you feel the coldness going into your hand. In reality, what's happening is not the coldness going into your hand, it's the heat being drawn out of your hand to the ice or to the snow that's making it get cool and melting the snow at the same time. Now, in chemical reactions, we start studying a certain aspect. There's a lot of things you can study, but we point out a certain part that we're going to study, and we call that the system. The system is the part of an experiment that are singled out for study. So, for example, in a chemical reaction, the system would be the chemicals in the solution, maybe, or generally chemicals taking place in the reaction, the solution, the water, the flask, the air around it, all that would be considered to be the surroundings. Now, when you talk about systems, then, there are three types of systems we deal with. The first is called an open system. An open system is simply a system in which matter and energy can be exchanged with the surroundings. So if we have a flask or a bottle that's open and you can dump new chemicals into it, keep reacting them, and energy and heat can flow out of the bottle and into out of the bottle, that's an open system. A closed system is a system in which only energy can be exchanged. So the bottle might be a cork in it, so you can't put any new material in, or no steam can come out, no chemicals can be spilled out of it, only the heat energy can flow through the glass out of the bottle. An isolated system is a system in which neither energy nor matter can be exchanged with the surroundings. Think of this as more of a thermos kind of situation where you have an insulated system. You have coffee in a thermos, a stainless steel thermos that's very insulated, and you hold the thermos on the outside and it doesn't feel hot at all if you have a really good thermos. That's an insulated or an isolated system. That's why I always like to think of it as insulated as well as isolated. Now, when the energy flows out of a system to the surroundings, we call that exothermic. So in a chemical reaction, if heat is given off to the surroundings, that is an exothermic process. The way you can remember that is exo means exit in Latin, or to go out. If an animal has an exoskeleton like a spider, it has a skeleton that's on the outside. So an exothermic process is a process in which heat energy is flowing out to the surroundings. An example of an exothermic reaction would be those hand warmers you use in the wintertime. You shake them up, you open them up, you shake them up, and they start to give off heat. As they're giving off heat from the chemical reaction, the heat is flowing outward to your hands and to your body, keeping you warm. If energy is being drawn into the system, it's called an endothermic reaction. In an endothermic reaction, heat energy is being absorbed from the surroundings to the system. Generally speaking, endothermic reactions are a cooling process. Right? Things will, to your hand, when you put it on your hand, it would tend to be cold because it's drawing energy in from the surroundings, and your hand would be part of the surroundings. An example of that would be a chemical ice pack at a sporting event. If you've ever been to a sporting event, or if you've ever been injured at a sporting event, you may have seen the chemical ice packs. They squeeze together and they shake them up and they get really cold. That is a endothermic reaction. It's drawing energy in from the surroundings. All right, so we've talked about system and surroundings, and we will use those terms as we move forward into this chapter.